Hi, Mark here with My Engineering. For today's video, we're going to be doing an end-to-end workflow on how to scan an object, process it, and then export it so that it's ready to bring into your 3D printing software and then print that same object. For the test piece today, this is actually a request from one of our engineers. His kid is looking to get this little badge scanned and then shrunk down and printed so that he could play with it with his Lego set. Um, the process is actually quite simple. I'm going to show you guys how to do that. And for doing that today, we're going to be using our Artex Space Spider 2 and Artex Studio 19. So there are a couple of things that we need to consider before we actually start our scanning process. And one is that for the purpose of 3D printing, we need to have a watertight mesh. So I can't really lay this flat on my turntable. I'm not going to have any data for the back side of it. And if you're to scan it and then flip it over and scan it, on a very thin object, it can be difficult to get a good alignment between the two scans. So what I'm going to do instead is I'm going to scan it in the vertical position clamped. So I'm going to clamp it like this. I'm going to scan it once. I'm going to move the clamp to the opposite side and then scan it again. Once I delete where the clamp is, I can do an alignment and have a complete mesh between the two with a very good degree of accuracy. The other thing is it's a relatively shiny object. So I'm going to use Atablime scanning spray on this. I'm going to use our AB6, which is a 6-hour sublimating spray. We only need a light dusting, not a whole lot, but it'll give a lot better chance for a good return for the scanner. So again, we're going to have a nice, sharp, clean model. All right, so we are looking at Artex Studio 19 right now, and we can start our preview on the scan. I do have automatic base removal enabled, so you can see that grid there. When we start recording, it's going to remove everything from the turntable down. You'll see our object is populating as it comes around. Scan one done. We're going to flip it around and then do another scan. All right, so I've flipped my piece and now I'm going to scan the opposite side. Now we got to put the two pieces together. All right, so I've completed both scans and I've deleted some of the noise and the clips that are from each scan. You can see that the raw data is just kind of presented here from the purple is our first scan and then the red and the blue are our second scan. So now we just need to bring the two pieces together. So we're going to use our align tool. That's going to bring us here. So it'll align group number 1, which is our second scan, to that Spider 2 scan number 1, which is our first scan. And all we need to do here is select some common points between the two scans. Here, we'll use this guy. And why don't we just put one over there on the tip. Further apart you space these, it kind of gives it a little bit better information to work from. That should be enough points there though. So we're going to align the markers. You can see they actually align pretty good just by lining them up. But then when we hit align, it'll do a best fit from that data there. It kind of corrects it a little bit. So we're getting pretty close. Now we're just going to go to tools and we're going to do our registration. And what that's going to do is going to do that the fine corrections between all the frames and the frames between all the different scans. So with the registration complete, it's sharpened it up, but it still looks a little bit noisy. We're still looking at the raw data. We're going to do two last little steps here. We're going to remove some of the outliers, see if it just cleans it up a little bit, and then we're going to fuse it. Now with the outlier removal completed, you look at it's starting to look pretty clean. We're going to do a fusion. So I'm going to fuse this at 0.1 of a millimeter. I know there's a lot of fine geometry in there. We'll see what it looks like. And I want the whole filling to be watertight. Let's run that algorithm and see what happens. Well, there's a couple more steps that we need to take before we can actually export this, but I'm going to take another quick minute. I'm always so impressed with how well this scanner performs. But when we get in really tight here, you can kind of see. So I have it in wireframe mode right now. There's an insane amount of data. These triangles are just absolutely tiny. So I'm going to first do a mesh optimization, which is the same as like a decimation or simplification. And right now I have it just set at 10%. So it's going to do essentially 10% of the triangles. It does a really good job of keeping the smaller triangles in Artex Studio where you have a lot more changes in geometry, and larger triangles where it's flat. So you can kind of see that here in these flat sections. The triangles become quite a bit bigger, but if you look at the wings on the eagle here, you can see there's quite a bit smaller of the triangles. So that'll probably work pretty good for the next steps. We're going to go back to solid. And you can see the details still preserved, especially if we're going to be doing 3D printing on a very small scale. The next step I'm going to want to take is I'm going to position this so that the XY axis is on the flat. It's not totally necessary, but it'll just make it easier, especially for most the 3D printer software where you don't have that, that capability to move it around very easily. So I'm just going to do just a rough positioning with 3 points on the XY. And we can see here now the bottom is oriented down, so that is sitting flat as if it was going to be on the printer tray. I'm going to apply that. So now we have simplified our model and we have oriented it on a new origin. I'm going to duplicate the one that we have here. And the reason I want to do that is I'm going to reduce the size of this. So if you remember back to the start, I want to print this badge, but I want to do it in a very small scale. So we're going to reduce it to about 10% of the size. So again, we're going to go into our editor, and there's a transformation tool, and scale is the third tab on here. And so instead of a scale of 1, we're going to do a scale of 0.1. Hit enter, and you see that reduces it. So our original here in the green, and then our 10% scale version way down here. And now all we have to do, we're going to click on that and export the mesh. We're going to do it on our desktop, and we're going to call it badge. And so when we import it in our 3D printing software, we're just going to import badge, and it will be the right scale. It'll be already oriented, and we just have to go print. So our 3D printing was successful. However, the scaled down little model was a little bit small to actually complete this video. So I printed a 1-to-1 scale model as well. You can kind of see them both here. They both look quite good. Well, both look very good. The original looks good. The 3D printed version looks pretty good as well. However, the extruder on the 3D printer that we're using right now is 0.2 mil size. So you actually do see a fair bit of layer height. So what we're looking at here on your screen, on the left-hand side is the model that we scanned of the badge, that and we scanned that with the Artex Spider 2. The one on the right is the 3D printed model scanned with the same scanner. So it does look a lot more like a topo map. That's because you see the layer height of the 3D printer. If a lot of you guys are familiar with 3D printing, you probably anticipated this before I got this far in the video. But it does actually look very good. The scale is darn near perfect. The only difference is that it doesn't get that really fine geometry because the way that 3D printers operate. So now here I'll just show you in the full screen the results of our 3D printing, if our camera could focus quite right. Not a very difficult workflow in order to take a real world object, scan it, process it, and then 3D print a somewhat very close replica of that object. Dimensionally perfect, maybe just the fine little details, depends on your printer. If you guys would like to see any other workflows, or if you have any more questions about the Artex Spider 2, always feel free to reach out. You can reach us at support@myeng.ca, or you can leave a comment below. Thanks for watching. We'll see you in the next video.